Welcome to The Explainer. Today, we're diving into one of the biggest, most fundamental ideas in all of physics. It's a concept that explains how, in a universe that's supposedly started out simple and perfect, we get, well, anything. How anything at all comes to exist. Turns out, it's all about a creative and totally necessary flaw in perfection.
So let's just start with this huge question. If the Big Bang created a universe that was incredibly simple, almost perfectly uniform, this sort of cosmic soup where every bit was like every other bit, why isn't it still like that? Why is it now filled with all this amazing, specific, complex stuff? I mean, stars, galaxies, planets, you and me?
Well, the short answer is the universe just isn't a fan of that perfect balance. It actually thrives on shattering it. This process, this moment where perfect symmetry gets broken, is the engine that creates pretty much all the structure and order we see around us.
Okay, so to really wrap our heads around this, we need to look at a really simple repeating pattern. And this is a pattern that shows up at every single scale of reality, from the tiniest quantum particles to the entire cosmos. And it all starts with something you could do on your desk right now.
Think about this pencil. When it's balanced perfectly on its point, as you see there in step 1, it's in a state of perfect symmetry. It could fall north, south, east, west. Literally any direction is equally possible. But, it can't stay like that. Step 2 is the break. The tiniest little wobble and bam, that balance is gone. And in that moment, it has to pick a direction. That choice creates step 3, a new order, a specific reality where it fell in one direction and not all the others. This little 3-step dance is the key to everything we're going to talk about today.
So what we just saw with the pencil, it actually has a formal name, symmetry breaking. It's when a system that's in a totally balanced symmetric state, just spontaneously, and that's the key word, it means it happens on its own, moves to a less symmetric state. And in that one moment of choosing, it creates something from nothing, really. It creates new information, new order, and new structure, where before there was just uniform potential.
Now, I know this might seem a little abstract. A falling pencil? Sure. But let's apply this exact same pattern to something you experience every single second of your life, your own personal sense of space and time.
You see, from the grand bird's-eye view of physics, especially Einstein's relativity, there's no real fundamental difference between space and time. They're all woven together into this single four-dimensional fabric called space-time. From that perspective, there's no special here and no special now. It's all just one big, symmetric, unified map.
But that's not how you experience it, is it? Not at all. Your consciousness, your point of view, is the symmetry break. As the slide shows, you take the universe's unified view and you shatter it. You break that single 4D reality into a much more personal 3+1 version. 3 dimensions of space you can move around in, and 1 dimension of time that you travel along. You create your very own unique here and a unique now, breaking the universe's perfect symmetry to create your personal journey through it.
So what does this break actually do for you? Well, it creates what physicists call your proper time. That's the time that's actually ticking on your personal clock. It creates proper acceleration, the g-force you physically feel when you speed up. And, this part is wild, it's the reason why 2 people moving at different speeds can genuinely disagree about which of 2 distant events happened first. Your subjective reality is literally a product of this broken symmetry.
Okay, so that brings us to another huge mystery. If breaking symmetry is what gives us our sense of time, why does that time seem to have a direction? Why does it only flow one way? Let's take a look.
This is a really big puzzle in physics. Most of the fundamental laws of nature, from gravity to electromagnetism, they're time symmetric. They don't care if time flows forward or backward. A movie of planets orbiting the sun would look totally fine if you played it in reverse. But in our lives, eggs don't unscramble themselves. We remember the past, but we never ever remember the future. So why?
And yep, you probably saw this coming. It's because the universe performs another massive symmetry break. It breaks the perfect, elegant symmetry between the past and the future, creating a clear distinction, a one-way street that we all experience as the forward flow of time.
This is known as the arrow of time, and the source material we're looking at explains it with this really cool idea called subsystem correlation fading. Okay, that sounds complicated, but let's just break it down. Think about an egg again. Before you crack it, all of its parts, the shell, the yolk, the white, are perfectly connected. They're correlated. But when you crack it and it splatters everywhere, those connections are lost.
Correlation fading just means it is way, 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 way easier to lose those complex connections than it is for them to all spontaneously come back together. You can't unscramble an egg. It's this irreversible loss of connection, this fading of correlation, that gives time its forward momentum.
So we've seen how this pattern works in fundamental physics, right? But it isn't just for cosmic level stuff. It is, and this is amazing, the fundamental logic of life itself. It's happening at every single level of our existence.
I mean, think about it. At its very core, what is life? It's about creating order out of a messy, chaotic world. And how does it do that? It does it by breaking the symmetry of a uniform space, by drawing a line, a boundary, that separates an inside from an outside.
And what's so incredible about the slide is it shows you how this exact same principle just scales up and up and up. You start with the uniform soup of chemicals in the universe. Then a boundary, a cell membrane forms, creating a cell. An inside that's now separate from the outside. That exact same logic creates skin, defining an individual organism. That same logic creates the social boundary of a family, separating it from others. And it keeps going, creating the shared ideas and norms that form the boundary of a whole culture. Every single step is a new symmetry break, creating a new, more complex layer of order.
All right, so this cosmic pattern creates space-time, it creates the arrow of time, it creates life itself. But what about us? What's our role in all of this? Where do we fit in this grand story?
Well, it turns out we're not just along for the ride. We aren't just the things that are formed by all these symmetry breaks. Our role is way more active, way more important than you might think.
The source material for this explainer uses this beautiful phrase. It suggests that we, as conscious beings, have a kind of mandate. Our purpose, our job, is to be correlation propagators. So what on earth does that mean? It means our job is to create and to spread new connections, new patterns, and new kinds of order.
And this right here, this brilliantly illustrates our function. Every single time you learn something new, or build a relationship with someone, or invent a new tool, or even just tell a story, you are propagating correlations. You are taking the raw chaos of the world and forging new connections, new boundaries, and entirely new layers of meaning. In a very real sense, we are the universe's pattern-making machinery.
And so we end on this thought, this grand cosmic principle that order is born from broken perfection isn't just something that happens out there in space. We are doing it right now with every choice we make. Every line we draw between us and them, between what we know and what we don't, between an idea and a reality, is another symmetry break. So the question to leave you with is, what kind of order, what new worlds are we choosing to create?